Hello. Now, continuing our work in algebra, we are going to look at something called the factor theorem today. Now, the factor theorem is actually something we already know. We just perhaps didn't know that it was called the factor theorem. But there's no real new maths today. It's just going to be focusing on something we've already been doing in a slightly different fashion or with slightly different language around it. But the factor theorem just says that if we know a factor of a polynomial or of a function, then we can rearrange that factor in order to get the root of a function, and vice versa. If we know the root of a polynomial, then we can rearrange that in order to get a factor of a polynomial. We've been doing it for years. We just perhaps didn't know that it was called the factor theorem. So if we take a algebraic type example, if we know that a multiplied by x plus k is a factor of a particular polynomial, then we could set that factor equal to 0. We could find out what value of x is going to make this equal to 0 and rearrange it, and we get that x is equal to minus k all over a is going to be a root of that polynomial. So if this is a factor, we end up with this as a root of the polynomial. So let's put this into practice. Is 2x plus 3 a factor of our quadratic here? Now there's lots of different ways that we already know how to do this. We could just factorize the quadratic and we could see if 2x plus 3 was one of the factors. We could do long division and see if our factor, if 2x plus 3 divides perfectly into our polynomial, into our quadratic. If we get 0 remainder, that means that 2x plus 3 is a factor of our quadratic. What we're going to do now, just to highlight the factor theorem, and really for no other reason, is to practice it by saying we are going to look at, if this is a factor, we should be able to set it equal to 0 and find the root. And if we sub that value of x into our quadratic, we must get y equals 0 out at the end. So if we sub in a root into our quadratic, the root is the value of x, or the values of x, that makes the quadratic equal to 0. So if we rearrange this as a factor, this is a factor, set it equal to 0, and find the value of x that makes this equal 0, like what we would have done at the end of quadratic solving questions for years now. I take that. So if this is a factor, this must be a root. What does that mean? It means if I put in, if I say this is f of x is equal to this quadratic, f of minus 3 over 2 must equal 0. If this is a factor, then when we've rearranged it into a root, when I put in this value of x into my quadratic, I must get 0 out as an answer. So this is a way of checking if this is a factor. And we know lots of other ways, but this is just a way that it focuses on the factor theorem, which is what we're focusing on today. So let's put this in practice. We're going to have f of minus 3 over 2 is equal to 2 on minus 3 over 2 squared minus 3 over 2 minus 6. So I end up with 2 on 9 all over 4 plus 3 all over 2 minus 6. At this point, you could get away with putting this into a calculator, or you're not going to run afoul of the marking scheme if you put all of this into the calculator and just got a final answer. We add up our fractions and we get 12 all over 2 minus 6. 6 minus 6 is equal to 0. So we get that f of minus 3 over 2 is equal to 0. So that tells us that x plus 3 is a factor. So this is just another way of figuring out if we have a factor of a particular polynomial, a factor of a particular function. And likewise, if we were given a root, we could work backwards and find a factor. So that's the basics of our factor theorem.